Welcome to Saxon Math Course 3, Lesson 10. Today is all about rational numbers and equivalent fractions. Our objectives for today, after this lesson, you should be able to understand how the sets of numbers are closed or open under the operations of arithmetic, identify numbers as rational numbers, find equivalent fractions for a given fraction, use prime factorization to reduce fractions, compare fractions by rewriting them with common denominators, and write improper fractions as whole numbers or mixed numbers. Some review from lesson 9. Remember we talked about prime numbers. They only have two factors, one in themselves. Composite numbers have more than two factors. And then we use factor trees to find prime factorization. We also talked a little about divisibility rules. Those will help you quickly tell if a larger number can be divided by the numbers 2 through 10, except for 7. Remember, 7 didn't have a divisibility rule. So now we're going to talk about our sets of numbers. The set of whole numbers, which remember is 1, 2, 3, 4, 5, 6, and then also 0. So it's all the counting numbers plus 0. That whole set of numbers is considered what's called closed with the operations of addition and multiplication. So what that means is that if you take any two whole numbers, doesn't matter which ones they are, and you add them together or you multiply them together, you're going to get another whole number as an answer. That's why it's considered closed, because all these answers are going to fit within the set of whole numbers. They're all closed within, you can imagine it as like a circle. They're all closed within the circle. However, it does not work with subtraction or division, so we would consider the set of whole numbers open with those two operations, because you can get answers outside of whole numbers when you subtract or you divide. You can end up with fractions when you divide, and you can end up with negative numbers when you subtract, and neither of those are whole numbers. The set of integers, which remember are all the whole numbers and their negative opposites, that set is considered closed with addition, subtraction, and multiplication, so all three, because negative numbers are part of the set of integers. So that you're always going to get an integer as an answer. The only operation that doesn't work with is division, because division you can again end up with fractions as answers, and fractions are not integers. Now that brings us to talking about rational numbers. So rational numbers are any numbers that can be expressed as a fraction. So that includes all whole numbers, all integers, and then any fractions, 1/2, 2/3, mixed numbers, 2.5, anything like that, that wouldn't be included in those other sets that we've already talked about. So this set, the set of rational numbers, is closed with all four operations of arithmetic, because no matter which of those you do, you're going to end up with another rational number. If it's a fraction, if it's a negative number, it doesn't matter, because all of those are included in the set of rational numbers. There's only one exception, and the only exception is that you cannot divide by 0. If you think about it, it makes sense, because when you're dividing, you're splitting a number into equal groups, and you can't split a number into 0 equal groups. It's impossible. And even your calculator, if you try to divide by 0, it will say you can't do it. So that's the only exception to the set of rational numbers being closed with all four operations, is you can't divide by 0. Here's a Venn diagram. This shows a little more information than we need, so I want you to ignore the stuff I'm scribbling on right now, because we're not talking about that. We're only going to talk about up to rational numbers. So this is just a quick overview of what we just talked about. Natural numbers, remember that's the same as counting numbers, 1, 2, 3, 4, 5. That's the smallest group that we've talked about. So all natural numbers, all counting numbers would fit in there. Whole numbers are a little bit bigger because then you're just adding 0 to the mix. So whole numbers include all natural numbers plus a little bit more. Integers gets a little bit bigger because then remember you're talking about all the whole numbers and their opposites that are negative. So that's a little bit bigger group. And then the biggest group we've talked about are rational numbers. Rational numbers include everything that we've talked about so far this year. So that's just a little visual representation of where how these number sets are related to each other. They get a little bit bigger and they include each other as you move out. Let's talk about equivalent fractions. Equivalent fractions, you find those by multiplying both the numerator and the denominator by the same number. So if you're asked to find a fraction equivalent to 1/2, you could just take 1/2 and multiply it by like 3/3. So if you multiply 1/2 by 3/3, you end up with 3/6, which is an equivalent fraction for 1/2. Here's another example. 2/3 and 4/6 are equivalent fractions because both numbers in the original fraction, the numerator and the denominator, were multiplied by 2. 2 times 2 is 4, 2 times 3 is 6. That's how you get 4/6. Reducing fractions is kind of the opposite of finding equivalent fractions. So reducing fractions we do by dividing both the numerator and denominator by the same number. We did this last year, so hopefully you remember how to reduce. Normally we want to reduce a fraction to lowest terms, and we can do that in one of two ways. We can either find the greatest common factor between the two denominators, or between the two numbers, I'm sorry, between the numerator and the denominator, and we can then divide by that, or we can use prime factorization like we learned in the last lesson. So I'm going to do an example using both kinds of reducing. So say we have the number, let's do 15 over, how about 45? So if I were to find all the factors of 15, I'd be 1, 3, 5, and 15. 45 would be 1, 3, 5, 9, 15, and 45. So now I just find my greatest common factor, which is easy in this one. It's 15. Then I'm going to erase this because it's in my way. And I'm going to divide both top and bottom by 15. And I would get 1/3. If I did the same thing with a factor tree, so let's find the prime factorization. This one's easy because it's 3 and 5. 45, I would do 9, oops. I would do 9 and 5, and then 3 and 3. So then, let's get rid of this. Remember that answer was 1/3. And I'm going to put my prime factorization on top and bottom of the fraction. So I've got 3 times 5 on top, and I've got 3 times 3 times 5 on the bottom. Now all I do is I cross off like numbers from top and bottom. So I've got a 3 and a 3, I can get rid of a 3 and a 3. I've got a 5 and a 5, I can get rid of a 5 and a 5. When there's nothing left on top or bottom, you're left with a 1. So that would be 1, and then whatever's left on the bottom, third. So that's how we use prime factorization to reduce fractions. Changing between mixed numbers and improper fractions is something we need to do when we're multiplying fractions. Remember, improper fractions are any fractions that have a numerator that's equal to or greater than the denominator, and mixed numbers have a whole number and a fraction. So here would be a mixed number, and here would be an improper fraction, and I'll show you quick how to switch back and forth. So say we want to go from this mixed number to an improper fraction. We're going to multiply the whole number times the denominator, so that would be 20, and then we're going to add the numerator to that answer. So we would end up with 21, and you always keep the same denominator, fifths. So 4 1/5 and 21/5 is the same number. Over here, we're kind of going the opposite way. So we're actually going to turn this into a division problem, because that's what a fraction really is. And we're going to do 13 divided by 7. So 7 goes into 13 once. And then instead of writing a remainder, we're going to write our remainder over our divisor, our number in front. So 1 6/7 and 13/7 are the same number, just written differently. That's it for your video today. Make sure you work through your practice problems, post any questions you have to the discussion section so we can talk about them in class. Your next math assignment is going to be a test, and then we'll see you in lesson 11.